my gosh, how does anybody follow that? Welcome everybody to a live presentation tonight of the Great Conjunction. This is it. This is the night we've been watching for and waiting for months and months. And we'll be with you for about an hour. We're starting a little early. We can't view it yet. Sun just set a little bit ago. Still too bright in the sky to actually see the object, but it'll be up here in just a minute. I'm going to do more introductions in a minute, but I wanted to start with a poll question, and let me explain. So you will be able to answer on screen as we sort of like go through this. And what I'm trying to find out is how many of you are in a position sort of like me. I'm out in my front yard. I'm sort of like watching the night sky. I can be online and I can do it at the same time. Now, some of you are probably going to have to be, kind of tied to your computers in your living room or in wherever your den or wherever that is. But I wanted to just sort of get a sense of our viewers and how many of them, looks like a bit more than half, actually sort of like can view the night sky as we're going through the presentation, and that's really excellent. For those of you that can't, don't worry about it. We're going to give you some things to look for right after the show, or maybe there's time during the program where you want to just run, and we'll wait until it's in position. We'll wait until the planets are very visible and kind of give you a chance to do that. We can't possibly be exactly 50-50. That can't be right. So so anyway, that's what I kind of wanted to see, and just going to get a sense of that. So with that introduction in mind, here's where I am. This is my front yard. I'm sitting on my driveway. In fact, you guys are sitting on the bed of my pickup truck. And right next to me over here is a big old telescope. I brought this one home from campus. It belongs to the ASU Outreach Department. It's a 14-inch Schmidt Cassegrain. It's a Meade piece. And on the back of it, I think you can see that little thing. It sort of looks like a camera. That's because that's a camera. That's just kind of sitting there. It's organized. It hooks right up to the scope. And I can use that to sort of show the image. So I was out last night. I kind of had it. It looked really, really good. I can't wait to show it to you tonight. We're still just a little bit early. We're going to wait until it gets a little bit darker. We can kind of get it visible. And so watch for it. In about 5 minutes or so, I'm going to do another poll question. And we're going to ask if you can actually see it. So it's going to appear. Actually, I'll show you where it appears in my house. Can I do this now? I'll try it. So no, I got too many wires hooked up. I guess I can't do it. So I have a really good view across my driveway here, right to the kind of a palm tree across the street. And I know that the planets are going to appear in the sky about 1/3 up from the horizon, almost directly southwest. If you know which way west is, which way south is, go right in between in about 30 degrees, 25, 30 degrees above the horizon. And I think that's where we're going to find it. And I think it's going to appear here in just a couple of minutes. And I'll do another poll for those of you that are outside watching, and we'll try to get an idea when people actually get to first see it and all of that stuff. So I'm going to introduce some people here. So Mark Johnston is with us. He's not ASU. He's actually a member of the community, and he's got kind of some things set up and a little rig. And so I'm going to have him light up his screen and introduce himself and say where he is and what he's going to be participating with us tonight. Go ahead, Mark.
Hey, thanks very much. Yeah, this is Mark Johnston. I'm here in North Scottsdale, Arizona, just north of ASU. And I'm in my backyard. And I've moved my camera around here. You can see I have my telescope set up here, and that telescope is pointing at the moment at the moon. And I've got my, so you can see yourself here, computer. I've got a digital camera connected to my scope, and that's feeding data to my screen, and I'll be able to show you live images of the moon and perhaps some other things later on, depending upon how our time goes today.
Right. It's not just about the planets tonight. It's about sort of observing in general and what it takes to have some equipment and some idea about how to capture some of these things. So thanks, Mark. We'll be back with you in a little bit. I was going to go to Tom Marsden next. Tom is associated with ASU. He's a colleague of ours and also a past member or a past president of the East Valley Astronomy Club. Tom, are you on? Did we lose him? All right. I am going to move on. I'm going to go to Ted Blank. Ted, can you come on screen and kind of just give a sense of where you are and what you're doing? Thanks.
Happy to. Hi, everybody. Ted Blank here. I'm a member of the Phoenix Astronomy Society. I live in Fountain Hills. And this evening, I'll be broadcasting from the club at Adero on the border between Scottsdale and Fountain Hills. Fountain Hills being the 17th international dark sky community in the world. We've got good dark skies, and we've got an image of Saturn and Jupiter on the screen already. So pretty soon we'll be able to show you that.
That sounds great. Thank you. So we've got Fountain Hills, we've got North Phoenix, and I know Tom is in Tempe, so to see if we can kind of get him back on screen and see where that goes. Also helping to present tonight is Kevin O'Donnell. Kevin doesn't have a live setup, but he's an expert at astrophotography. He does it quite a little bit, and we're going to see some of his planetary images from that he has in his collection. I also have three students with us tonight. Alicia Hyatt and Alex Blanche are going to be presenting a little bit about missions to Jupiter and Saturn, so a little bit of background context about what that is. And Spruti is also, Spruti Kachere is here today, and she is also kind of just going to help us get organized with the questions, and she's helping kind of in the background. It looks to me like Ted has social distancing going on and face masking, or at least so he's got that going. So that's really good. Thank you. Then Meg Hufford is also on board. She's a colleague of mine. She and I run the community outreach program, the on-site version of the community outreach program, where people come and visit the university, visit ASU, and that's kind of a good job, but people can't visit right now. So we have been finding ways to be virtual. We've been finding ways to get out to people, and what better opportunity than the Great Conjunction. And so we'll see this as we go forward here. So you can see there's some sort of people over at my house too. So this is really a pretty big deal. And I have some other neighbors just wandered up a minute ago because they see my activity out in the driveway. So they're seeing. And then lastly and not leastly, Kim Baptista is the webmaster tonight. She's the one that kind of has done the communication. She's got you organized, and she's got everything going. We will be able to answer questions as we go along. So if you want to just sort of like get used to going to the question and answer button, you can't chat, but you can ask questions. So just, if you wouldn't mind, you don't have to say name and last name and all that stuff, but just say who you are. If you're a student or a youth, I would love to know what grade you're in. That would be great. And if you have questions, our team will sort of be working in the background, and we'll just filter them into the presentation every once in a while as we go along. I think that is all the housekeeping. The way this is going to work is I'm going to show you some simulations of what we're looking for, the context behind what's happening in those planets. We will be back out here in just a minute. I'm going to take a moment, move inside, show you some simulations, and then for those of you that are outside, it's only a matter of minutes. I've just checked. I'm looking. Oh, I can see it now. So I just found Jupiter and Saturn. I see where they are in the sky. So let me go do the simulations. We'll come back, get the telescopes adjusted, and then we'll sort of like go on to the next portion of the show. Sound good? While I'm going inside, you're going to see another video, and I'll introduce the director of the School of Earth and Space Exploration. She's going to kind of walk you through what does Earth and Space Exploration is. Right, as soon as that's over, I'm going to be in a different location, and I'm going to show you a different screen. Here we go. Thanks, guys.
Here at the School of Earth and Space Exploration at Arizona State University, we are deeply committed to high-impact scientific discovery. We ask important questions with deep consequences for humanity as we explore the great unknowns of the Earth, our solar system, and the universe. Our students work with faculty in astronomy, cosmology, geosciences, planetary sciences, exploration systems engineering, and science education. We are breaking down the boundaries between these disciplines to answer the biggest questions that cannot be answered within a single discipline. Our degrees are designed to challenge students, to encourage critical thinking and scientific inquiry, and to inspire exploration. At the school, we're exploring all of Earth's continents and looking at the future in terms of climate and water supplies. We study astrobiology and seek to understand the relationship between life and a planet. We're at the very center of the community trying to understand whether Mars is habitable, maybe even in the present day. We have one of the largest collections of meteorites in the world, the largest at any university. And we have some of the best university facilities for building flight instruments and spacecraft for exploring our moon, planets, asteroids, and the unknowns of the universe. Here at the School of Earth and Space Exploration, we are combining the strengths of science, engineering, and education to set the stage for a new era of exploration of our Earth, our universe, and of the future.
Very, very good. Excellent. I am just going to take a quick little test here, make sure that I can be heard. So if somebody could give me the heads up and tell me everything's fine that way.
Perfect on our end.
Thank you. Very good. And so what you should be seeing on the screen is a little sort of bottle of the solar system. Now, this isn't the whole solar system. I'm only going to use the planets we were talking about tonight. I'm going to introduce you to the characters of the show, as it were. And what you see is the sun's in the middle. That's one of our characters, right? Everything revolves around the sun, so that has to be in position. The Earth is moving around very, very fast. I have this sped up a lot. And you can see how Jupiter and Saturn just kind of lap each other every once in a while. When that happens, that's called a conjunction. That's really what it is. And that actually happens about every 20 years. So that's actually not that rare. And so the definition of a conjunction is, here it comes again, watch, 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 watch. There it goes, Jupiter passes right by Saturn, like two race cars in a track and one passes the other. So every 20 years, approximately, that happens. That's kind of common. What's going to happen tonight, though, is they're also aligned so that they're going to be very, very, very close to each other. And that doesn't happen very often. And so what happens, the reason for that is, if you can kind of describe, the solar system has a plane. I usually think of an equator around the sun, and then you just expand it out into space, and that becomes the plane of the solar system. All planets have their orbital properties, and one of the orbital properties is what's called inclination of orbit. Not all of them are actually on the plane. Some of them more than others. Mercury has quite a little bit of inclination. So that means it rides above the plane of the solar system and then back through the plane and down below. All planets do that to a little bit of an extent. So the magic tonight is not only that Jupiter and Saturn are meeting the same ecliptic longitude in space, that's the conjunction part, but they also happen to be at parts of their orbit where we call their meeting node. That means they're passing through the plane of the solar system. So they're in line for us together, and they're very, very close together to the plane of the solar system. And that's what makes that happen. It has happened a little bit before. I think you guys have been watching the media. I'm actually going to just kind of set us up. It takes me just a second to get this. I'm going to go to the last time it was kind of like this, and you might have already heard that this happened in 1623. That would have been just a little bit after Galileo was making discoveries with his telescope. Let me just go to there right now. And so you can see I'm just going to have to advance that just a little bit in time. I'll sort of like start with a day or two. And I'm a month off. That's my problem. Let me just move forward a little bit. And so you can see in this thing, in fact, I can annotate for us a little bit. Let me just sort of like draw a little line here. Here's Saturn. I can come right through Jupiter. I can go right through the Earth. So there is the last time we had a really good alignment like we have tonight, but there's something wrong. Can you see what's wrong? Yeah. So when this was all aligned and everything was magical, the sun was in the way. So people, astronomers, I think Kepler and I think Galileo and I think the astronomers, they probably would have known what's going on, but they wouldn't have been able to view it, and they didn't have telescopes. And so the time it happened before that, where it was actually viewable, we have to go back a lot farther. I'm going to go to 1226. Hang on a second. I'm just kind of adjusting dates. Go to my way back machine here. And it's going to be 03 and 03. Let me just try this. We'll sort of go to there. Let me erase the line I already have on the screen. That's kind of right. So you can sort of see, here's the Earth. Let me just sort of like draw that line again, if you don't mind. Now I'm going to come from Saturn through Jupiter and through the Earth. So there you have the alignment. That was the last time that this particular thing was viewable to us Earthlings, where people would have been able to actually see what we're going to see tonight. That's a long, long time ago. And again, this was way before telescopes, 400 years before telescopes. So what we're seeing tonight, you're going to see views in the telescope eyepieces, or we're going to project those for you. You can see both planets in the same view. Now, understand, this has never happened before. People haven't done this before. And so we'll be able to show you that. Okay, I am going to unshare. I'm going to go back out to my station outside now that we've sort of seen how this works and how this alignment is happening. Oh, I wanted to show you one more thing. Sorry about that. I'm going to stop sharing for a second, and Alex is going to play a quick little video for you. I'll help set it up.
Yes, let me just pull that up real quick. Yeah, so this is a animation of the night sky. Here we go. Perfect. And you can see this, right, Rick?
I can sort of see what's going on. So what you see going on here is the movement. And would you just play it one more time for me, please? I just sort of like missed your start because I was getting set up for another thing. What we're doing is we're starting this back on October the 15th. And so we've been watching all the way through the holidays, all the way through Thanksgiving, all the way through Halloween and Veterans Day. Now we're kind of getting into December. You can see that the planets are sort of like getting closer and closer together. They're sort of moving forward, and now it ends tonight. Now, if you don't mind, Alex, I'm going to just share screen again. Let me sort of do that. I'm going to go to here. Am I optimized? I am. And so now I've kind of set up this model just a little bit differently. You can see that there's Jupiter and Saturn, and I've set up again in October 15th. So that view that started the video where we saw the two planets next to each other and separated in space by quite a little distance, this is where we were. I'm going to kind of run forward in 12 seconds to today and just going to watch what the movement does. Oops, I didn't do that right. Okay, now I'm going to run forward in 12 seconds. Just watch what the movement does. See how the Earth is moving around? It's coming closer to us, and it's kind of now starting to move behind the sun. Jupiter is moving a little faster than Saturn in space, and there you go. Now we're at today. So this is what's been going on. The planet's been doing their work in their orbits, moving through space. We've been watching for the last 3 months, and them sort of coming closer and closer together until they're actually going to meet and sort of be in space. And that's where we go. I'm going to stop sharing screen and move outside again. And what I want to do is launch the next poll. And that's going to ask those people that can see if they've found it yet. Are you actually looking at the object in space? So here we go.
All right, I believe I am back. Can you guys hear me okay now?
We can hear you.
Excellent. And I suppose you can see me now. Sorry, I actually came out here and I forgot I left my earbuds inside, so I had to run back in again. But here we are. So now it's getting dark. I can absolutely see it. So I see from the poll that people are having trouble. So I'm going to go back to that description, southwest. I'm going to say about 20 degrees above the horizon. And actually, I can start to see now that you can actually see both objects. And so both Jupiter and Saturn are visible. I am going to adjust my telescopes, but before I do that, I want Mark, I'm going to introduce him again, and we're going to go back to the view that is just of the moon for a moment. And then we'll get the telescopes organized and oriented towards the Jupiter-Saturn movement. But if Mark, if you wouldn't mind coming back on, and let's go ahead and just take a look at a good moon shot. People can sort of still get organized and sort of find the objects in the sky. And I will be back after I get my telescope adjusted to the planets, okay? Mark, are you there?
Yeah, I'm here. I'm not seeing the share button though.
Okay. I'll let you totally find that share button. Hi, guys. Uh-oh. Uh-oh.
If we start acting really skittish around you, trying to appease
Yeah, Kimberly, can you help me with that? I'm not able to share.
It should be on the bottom, share screen.
It's not.
Are you still seeing the chat and poll features?
I'm seeing the video summary on the right side. But I'm not seeing, it says recording, it's got people's participants there.
Hmm.
I saw it earlier, but it's not there now.
Silly technology.
Weird. Yeah, that seems more like a glitch.
Yeah, because it should be kind of in the bottom, in the center of your screen.
Should be.
Kim,
Let me go back to my screen, and I do have a little view of the planets now, so I can sort of show you what that looks like.
We'll try again.
Want to see it in the telescope? Let's see here.
Yep. So I now have the view on screen through my little setup. That jerking you see on the screen is me just kind of adjusting my focus, trying to get it in just exactly right. I'm going to put myself on the bottom here so you can kind of see me talking. Look, there's somebody next to me. What's your name? Lincoln. Lincoln is next to me. Thank you for wearing your mask, Lincoln. Those are moons. So what everybody is seeing here, if you look at my screen, is Jupiter is the big round bright thing at the bottom or in the middle of the screen. The oval shape up towards, I think you might be able to see my cursor. This is Saturn over here. These are 3 of the 4 Galilean moons. This one is Europa. This one is Io. This one is Callisto. The one that's missing is Ganymede, and Ganymede just about an hour ago passed right across the edge of Jupiter right here, and it's just right at the tip of my my cursor. So all 4 are sort of there, but you can only see 3 of them. I think also, if I have it right, let me just see if I can get a little bit better brightness. Hang on 1 second. I think if you have it, you can see just up here next to Saturn, see that little tiny dot right there? That is going to be the moon Titan. So Titan is one of the major moons of the solar system. We have 4 over here, 1 hidden. One is
Rick.
right there. Yeah.
Are we meant to be seeing your screen? Because we don't see anything on our end right now.
Oh, I sorry. Oh no, that's really bad. Oh, shoot, I sort of had everything kind of organized for you to be able to see that. Hang on a second. Let me launch again. Do I have to go over that all over again? Hang on a second. Cam live. All right. Can you see that now?
Yes, perfect.
Always.
Excellent. Sorry about that. My goodness sakes, I've just been talking and talking. So this is this is going to be Jupiter. Can you guys see the cursor? Is that good?
Yes, we can.
Okay. So Europa, Io, Callisto, and Ganymede is just right in here. This is Saturn, and this is a little moon of Saturn called Titan. Let me take a break here for just a moment. I'm going to actually ask Ted to get ready.
I can
And
share
I'm going
now.
to just change my, change my view characteristics just a little bit. And I'm going to play with it. Ted, why don't you come on? Do you have a view of the objects now?
Hi, Rick. Yes, I do. I'll share my screen
Okay, I'm
here.
going to stop share, let you go.
All righty, here we go. So, hello everybody. This is Ted Blank. I'm up at the Club at Adero on the border between Fountain Hills and Scottsdale. And right now, what you're seeing on the screen is a lower exposure, a shorter exposure version of what Rick was showing you earlier. So in this case, I don't have enough exposure to show you Jupiter's moons. They're too faint, but you can see Saturn's rings. And so this is the short exposure version of what Rick was showing you earlier. The idea here is that Saturn and Jupiter are illuminated at greatly different levels. So it's impossible for any one of us to show you both of those things properly exposed at the same time. So we'll switch back and forth between the ability to show you one and then the other. You can see Jupiter as a big bright disk in the sky, and you can see Saturn with its beautiful rings tilted slightly off horizontal. We can see both of them in the sky, naked eye, from up here, and we've got several folks behind me with binoculars and masks, and most of the people with younger eyes are telling me that they can see both Jupiter and Saturn naked eye in the sky. But we've also got a pair of binoculars, two pairs of binoculars to pass around, and with a pair of binoculars, it's really quite simple to see both of these objects. Let me show you a quick picture of the setup that we are using here. I'll just hold this picture up in front of the camera. That's probably the easiest way. There we go. So I took this a few minutes ago when it was light out. I've got a small telescope on a small mount, which is tracking the sky. And I'm sitting in front of a laptop that's doing the broadcast. And at the same time, we've got that mirrored over to a larger television screen, which is what most folks standing behind me are watching at the same time. Rick was mentioning Ganymede. Let me, if I could take a second here, I wanted to give you, well, if there's time for this, Rick, come back to me and I'll show them that occultation of the star by Ganymede last night.
Oh, that's right. Let's see. I think let's do it right now, if you don't mind, Ted. I forgot that you said you did this. And so let me set up a little bit. Both I was out here kind of like testing my system last night, and I noticed that all four moons were visible then. And one of the moons of Jupiter actually had a little star next to it. So Ganymede was visible, and right next to it was a little star. It looked like Jupiter suddenly had 5 moons, not 4. I identified it as a star. I found it today, so I did that. But Ted saw it, and they've actually taken it to a whole nother level. So explain what you did, Ted.
Sure. Let me share that. Let me share that screen for a moment. I'll stop sharing that, and I will share a different window. Here we are. So yeah, last night we
knuckle bump.
Yeah,
there was
I'm
a
hungry.
scheduled
That's why.
event where Ganymede, the third moon of Jupiter, was going to pass in front of a star, and when Ganymede went in front of the star, it would block the light from the star, and so there would be a small dip in the combined light of the two objects. The star would disappear, and the amount of light the star contributed to Ganymede, which was a very small amount, because Ganymede's a very bright object, would be hopefully visible. And so this is a recording of the light of the combined Ganymede and star on the left and the right. And then in the middle, you can see where the star disappeared behind Ganymede as Ganymede moved in front of it for about 130 seconds. Ganymede is huge compared to asteroids that typically do this. And this was part of the research for NASA because the JUICE mission is going to explore Ganymede. And one of the things that they're interested in is to know exactly where Ganymede is. And so measuring its the point at which it occults a star to the nearest 30th of a second gives some very accurate information about exactly what the parameters of Ganymede's orbit are. They're known pretty well, but any improvement in the knowledge of its orbit improves the ability of the mission to pass close by the moon and get better scientific data in the future. So we had 5 or 6 people around the country actually able to record this, and the data is being reduced right now. So let's go back to our live
Thank you,
image
Ted.
here.
That's absolutely amazing. And so did you know that was going to happen, or did you just you saw it in front of you and then you just did it, or how'd you get that?
I'm a member of an amateur group called IOTA, the International Occultation Timing Association, and our members, some of whom are rocket scientists smart, predict these things months in advance for us so that we can go out and be ready, assuming the clouds cooperate, and try to capture these events. So we knew about this weeks in advance, and we did some practice sessions several nights before because we knew the sky was going to be very bright, but luckily it was just dark enough for the data to actually be usable.
Excellent. Okay, so here's what I'm going to do next, if you guys don't mind. Thank you very much, Ted, and this is
You
great.
bet.
So I think this is really great because you have an image where you can see Saturn better and sort of have the lights better. In my image, let me just sort of share. Let me see if it's ready. We just share again. We've got we've got kind of things organized so that I'm not seeing Saturn anywhere near as well you are, but I have a really good sort of view of those planets. I mean, the moons of Jupiter. So we'll be coming back to these. I'm going to go offline here and make some adjustments. I'm going to turn the program over to our students, Alex and Alicia, and they have put together just a real quick little slideshow and explanation of missions and explorations that have recently gone to Jupiter and Saturn, and some of the work that ASU does associated with Jupiter and Saturn. So I'll be back as soon as they're done. Thank you, guys.
Thank you, Rick. Okay, so yeah, we're gonna, I'm gonna introduce myself. My name is Alex Blanche. I'm a sophomore student at Arizona State University. I'm part of our docent team, so I work at the gallery usually, but I've been helping out with virtual shows, and I'm gonna talk a little bit about just some of the missions to Jupiter, and then after that, my coworker Alicia will talk about Saturn. So first, let's talk about Jupiter. It's the largest planet in our solar system, the gas giant. And we're going to talk about the many past, current, and future missions we've had to better understand this planet. So one of the first ones is the Voyager missions, 1 and 2. Both of them were launched in 1977. The Voyager 1 only went to Jupiter and Saturn, and Voyager 2 went to Jupiter, Saturn, Uranus, Neptune, and beyond. These were both intended to study the gas giant planets. Currently, they are both now in interstellar space, which means they are out of our solar system, kind of we consider the boundaries. Voyager 1 is about 23 billion kilometers away, and Voyager 2 is about 19 billion kilometers away. So that's about 21 light hours and 17 light hours. So it takes us a long time to communicate with them if we have. Also pretty old, so we don't always have that reliable communication. And these are actually the spacecraft that carried the famous golden records that Carl Sagan, the famous astronomer, helped create. If any of you guys watch Cosmos, he actually helped create these golden records that had a bunch of information about humanity. So those were those missions. And then we also have the Galileo missions in 1989. This is a mission to study Jupiter and its moons. It was the first spacecraft ever to orbit Jupiter, composed of a probe that was sent down into Jupiter and then an orbiter which orbited around it. It studied Jupiter's atmosphere and its clouds. It studied its moons of Io, Europa, Ganymede, and Callisto. And then eventually it was retired in 2003 by flying into Jupiter's atmosphere and burning up. Then we have the Cassini-Huygens mission. This is loosely connected to Jupiter. It was actually meant to study Saturn, but it passed by Jupiter on its way. So we got some pictures like this, and it flew by Jupiter in the year 2000. So just skim by before moving on to Saturn. You'll hear about that with Alicia. And then there's the Juno mission. This launched in 2011. It is also an orbiting probe around Jupiter, just like Galileo, and it is actually the second one of all time. This one was designed, it's actually a current mission. It's still being operated. Its purpose is to understand the solar system's beginnings and reveal the origin and evolution of Jupiter. It helped determine how much water was actually in Jupiter's atmosphere. It looked deep into Jupiter's atmosphere to measure composition, temperature, cloud motions, and other properties. And also it mapped Jupiter's magnetic and gravitational fields. So just learning a lot about the planet and its evolution along with our solar system. And then we have future missions. So one of them is called JUICE, launching in 2022. It stands for Jupiter Icy Moons Explorer. It's set to explore Jupiter and its moons Ganymede, Callisto, and Europa. Those are all of its icy moons. It's operated by the European Space Agency, but here at ASU, teams at our campus are actually developing the JANUS camera system, which is an instrument on the spacecraft that's going to help with those studies. So we're building that instrument. And then the final future mission is the Europa Clipper, 2023, 2025. That's about when it's launched, a little bit of larger window. It's going to be orbiting Jupiter, but it's actually going to be studying its moon of Europa. And it's going to be determining habitability, sorry, and a landing site for a future mission. And the reason we're so interested in the habitability of Europa is because there are liquid oceans underneath its surface. And so we think that, you know, if there's liquid water in there, there might be life. And so ASU actually is developing a lot of instruments for this mission. We have the Europa Thermal Emission Imaging System, or ETHEMIS. We have the Radar for Europa Assessment and Sounding Ocean to Near Surface, or REASON, the Surface Dust Mass Analyzer, or SUDA, and then the Mass Spectrometer for Planetary Exploration / Europa. And so we're all developing those here at ASU campus, and then they're going to be placed onto the craft, which will launch in a few years. But this is going to be a big step. Here at campus, we're really excited for this because Europa might be a haven for life, maybe, if there's life in the solar system. So very exciting. And then now I'll pass it off to Elisa so she can talk about the missions to Saturn.
Thank you so much, Alex. Hi, I'm Alicia Hyatt. I work at the Marston Exploration Theater, and I'm going to talk to you today about the Cassini-Huygens Saturn Orbiter and Titan probe. Awesome. So crucial dates for this mission. The Cassini-Huygens mission launched in, Huygens mission launched in 1997 to land in Saturn, or to arrive at Saturn in 2004. What's really exciting about this is one of the most important tasks that Cassini was tasked with was to release the Huygens probe so that it could touch down on the surface of the moon Titan, which it did. And this was the very first robotic explorer to land on any outer solar system body. So it was really exciting for scientists. But unfortunately, all good things have to come to an end, and the Cassini-Huygens mission was completed in 2017 when Cassini so bravely launched itself into Saturn's atmosphere and sending us data as far as it could. So we have lots of science from that. And so what exactly did Cassini accomplish? Well, it was the first to do a lot of things. As I mentioned, it was the first to have a robotic explorer to land on an outer solar system body, and it was also the first craft to orbit Saturn. It gave us extensive data with its 20 years of service, and we're still analyzing some of it today. Like I said, the extensive data that we're still analyzing, it not only gave us information about Jupiter and Saturn, but also Saturn's rings and its moons. And with that being said, it's a victory for science. It proved that we could build, and it proved that we could launch something to go into deep space and conduct lots of science for many decades. And so with that being said, I just wanted to share a few images that the Cassini mission took on its 20 years of service. was the first to orbit Saturn, but it didn't stop there. It orbited 294 times, collecting 453,048 images along the way. So we have a lot to analyze here. And with that being said, I want to encourage you to go to NASA's website and take a look at some of these images that Cassini took and see if you can kind of see what's going on the surface of these planets or these moons or these bodies and see what your science caps think are going on there. So with that being said, I'm going to pass things back to Rick, if he's here.
I'm here. I'm here. I'm here. I'm sorry. I also have the same problem everybody else does, trying to find the buttons in the dark and with multiple screens going at the same time. So, but I'm back. Alex and Alicia, thank you very, very much. You never disappoint. So usually we talk about this well in advance. We just kind of came up with this idea this afternoon about noon. We said, we really should just kind of put the context of exploration into this a little bit. And you've done an excellent job. So thank you very, very much for helping with that. The next thing, we're going to go back to Mark. Mark did work out his technical difficulty and the share, and so I'm going to ask him to share his screen. And because the moon is bright and up and obvious in the night sky, I thought we'd just take a quick look at that before we go any further. Okay, there you go. Thanks, Mark.
Are you seeing
Looks
that?
great. I sure am.
Okay, awesome, good. So I turned it sideways so we can take advantage of the screen completely, but a few key features here. These are the Maria. So you've got the Sea of Crises up here. You've got the Sea of Fecundity, the Sea of Tranquility, where the Apollo 11 landed, and the Sea of Serenity, and lots and lots of craters. This is the Terminator. So this is the vertical edge, if you're looking at it naked eye right now, at least from our latitude. And it's a beautiful object. It's taken a lot of magnification. You can zoom in on craters. There's just a lot to see. And as the moon goes through its phases, different features and shadows are highlighted by the angle of the sun on the moon. So it's a lot of fun to look at throughout the month.
Excellent. Thank you very, very much. So I just wanted to remind everybody, this is live. So this is a camera rig hooked up to a telescope looking at the same moon that I hope you are tonight. Before we go any further, thank you, Mark. I'm kind of going to get back to you in a little bit about a possibility of another object. But the next thing I wanted to do, I'm going to do that poll again. Now I want to know how many people can actually see it. So let's launch the poll is it visible to you? Are you seeing it in the night sky? I kind of want to know that next, okay? That's better. That's better, we're getting there. And I don't know if you've noticed this or not, everybody, but we have over 700 people sort of since we started tonight. So we're about 729 right now, sort of viewing with us. The outreach department at ASU, we've taken a really, really serious look at how we can stay in touch. And so the fact that there's a grand conjunction tonight is great, but we don't just wait for this. So we have a regular program we do every other Wednesday night. We're taking a little break for the holidays now, but starting up again in January, and then every other Wednesday for the rest of the spring, we do some sort of subject-oriented night sky viewing hour-long presentation. They start at 7:30 and they go until 8:30, and I'm sorry, they start at 7, they go until 8, and it's been a lot of fun, and many of you have done that. I know we have a lot of new visitors tonight because of the attraction of this amazing opportunity to see these planets, but there's stuff going on all the time. You can see people moving around in my background. I don't know if you know it, but you probably heard that I had kids, neighbors are walking by. There's some light on me, so everybody sees there's something going on here. But this has really been an amazing adventure. So I noticed that most of you that are looking now have a view of it. And I wanted to just kind of point out something we talked about here with my friends is that the news media sort of had this thing come in together, like both planets were going to be together and the combined light was going to create one single star. That's not what we're seeing, is it? Yeah, so tonight is as close as they're going to get. And I can definitely, I'm just looking at it right now, I can see Jupiter and I can see the much dimmer Saturn. Remember, Alex talked about Saturn being much further away, sort of in part of his presentation. Saturn is actually about twice as far from Jupiter as we are right now. If you remember the simulations I did inside. So Earth, Jupiter, and then Saturn about twice as far away. So it's a smaller planet. Not much, but a little bit smaller, twice as far away. So that owns the dimness and sort of the difference of it. I am going to switch back. Can you guys see this? Let me just double check. Are you seeing the image of Saturn and Jupiter again?
No.
Okay, hang on a second. Let me I can fix that. We've got so many different things like sharing and moving and doing. I just wanted to show you something I found. Here you go. Can you see them twinkling a little bit? Maybe that might be too much to ask of Zoom, but on my particular screen, I can see that it's starting to get lower and lower towards the horizon. And so we're starting to get into more atmospheric interference. And when we talk about imaging planets and we talk about anything we look at in the night sky, astronomers want to look at things that are straight up overhead. Because if it's straight up, it travels through much, much less atmosphere. And you think our atmosphere is clear, you think you can go out and see the stars, but it is loaded with moisture and dust and debris. And especially in the city, we have reflection of city lights. So we like straight up. What we have tonight is way sort of at the angle and almost by the horizon. And so that's interrupting some of our viewability of this particular object. I'm going to try a little adjustment here. I was doing it offline. Let me see if I can get that back on my screen here. If I just sort of like, I'm going to make everything else look really bad, but I can show you that if I make the rest of the sky really dirty here, let me just point at it. You see this coming into view here? That's that moon of Saturn I was talking about. So that's Titan right there. I took some astrophotography last night. I haven't had a chance to process the image, but if I make it really dirty, it's almost hard to look at because of all the stuff going on here. I think you can start to see, let me see if I can do it. You can see there's actually 4 or 5 other little tiny moons that are sort of like just dancing around Saturn. I know they're here. I'm not seeing them very well on my screen, but Titan is coming through. Let me just tell you something of significance here. In our solar system, there are 7 large moons, larger than all the other moons. So there's 7 big ones, and then everything else, all 63 or 165 other moons are much smaller. In this particular view with Callisto and Io and Europa, Ganymede hidden right here, Titan right there, and then the moon shot that Mark just gave you, the moon in the sky, you're seeing, right? You're seeing essentially 5 of the 7 moons that are big and bright. 6 if you want to count Ganymede against the moon. That's really pretty amazing. And the fact that all of those moons and these 2 planets, I'm going to say this again, are in the same telescopic view. This is the first time that humans actually been able to see this. So this is really a very, very auspicious night, if you want. It also happens to be on the winter solstice. Today happens to be the longest nighttime of the year, the shortest daytime of the year. The sun will start turning around and moving off of the, moving against the horizon back towards the month starting tomorrow. And so the promise of spring, the promise of that stuff is coming up. I'm going to kind of go back and introduce you to Kevin O'Donnell. Kevin is an astrophotographer. I introduced him at the very beginning of the show and sort of said he would be kind of coming up here about now. Let me just let him get on screen. I'll stop share. Let's give him a chance to do a little sort of share screen. And I want him to talk about some of his planetary images, how he gets them, how he kind of like figures out what to do and how and what to take. And so Kevin, it looks like you're wearing a NASA shirt. Thank you. Good job.
Thanks, Rick. So I have my background here of some of my images, but I'll go to actual share of them. You guys can see some of the stuff that I work on. Let's talk about it a little bit. So I'm Kevin O'Donnell. I'm an amateur astronomer and astrophotographer. And I recently added a star tracker to my camera setup, which I was actually outside working on when I heard my name called and ran in as fast as I could. Highly recommend that to anyone interested in astrophotography though, because otherwise you're very limited in your exposures. So going back to August just of this year, I was taking wide field 15-second exposures up in Flagstaff at Lake Mary. But it was frustrating because, it's limited to 1 to 2 seconds, especially at an 840 millimeter lens like I'm using. So a couple of months ago, I bought a star tracker and it just changed everything. It was just a sample of only this year and what I've been able to do in just the last few months. So anyone that's interested in astrophotography, highly recommend getting a star tracker because it'll really take it to the next level. You can do a stack of photos and not only do you get a longer exposure total then, but you eliminate a lot of the noise. So these are just some of the samples of my favorite images.
Excellent. Thank you very much. Do you have like a favorite Saturn or Jupiter that you've taken?
I've just taken some outside. This one in the top corner up here is just from last night. So you can see some of the moons of Jupiter.
I see. Yep, I got.
Yeah, one of the tricks that you'll see a lot of people posting their photos of Jupiter and Saturn right now is, unfortunately for the camera, if you make Jupiter where you can see the rings or the bands, you can't see the rings anymore, and vice versa. They're basically about a whole f-stop difference. So this is
I see what you're saying.
Composite. Yep.
Lots of challenges. So
I
think that's what kind of what makes the difference though is you understand the properties, understand what the capabilities of your equipment, what you can see and all that kind of stuff. This, we kind of talked about this among ourselves about a week or so ago, just so everybody knows. This particular image is really quite a challenge. I talked about Saturn being so much dimmer. It's actually 2.5 camera stops dimmer than Jupiter. So our technology isn't really set to do that. You can't say take the top of the screen, you can't automatically do it. Say take the top of the screen and make it brighter and take the bottom screen and make it dimmer. All of that can be processed after the fact in labs and things like that, but that's the view. And let me ask you, Kevin, if you can't, that's all right. But is there a way to get a close up of that image you're showing right now? That one? Do you have it like on your screen someplace? I know you put it in your composite.
Let me look for a moment. See what I can find.
If you can, because that relates to what Ted was talking about. Show you where that star and Ganymede are right next to each other, and how he sort of like dealt with that occultation.
Again, this is from the 19th, but as you say, it might be a little more helpful to what we're talking about right now.
There you go.
So on the 19th.
Oh, yes. Oh, I see. So that's what it is. Okay, I thought that was last night. So it's a little different. Yep. And everybody can see that the moons of Jupiter are in a different position. Io actually has a 17-hour orbit. So every night, if you go out and look at Jupiter in a telescope, every single night, those moons are dancing around. They're not even close to each other. So one moves very, very fast and can move all the way around the planet in less than a day. Europa, not much slower than that. And Ganymede and Callisto tend to take a lot longer to move around because they're further away from the planet. But that's kind of cool. Well, excellent. So did you say the Star Tracker is brand new? Have you used it before yet?
Yeah, I mean, so these photos I have here really show what I've been able to do in the last few months, from Orion to the Flame and Horsehair Nebula, even Pleiades, Cigar and Bode's galaxy. So before a few months ago, you could take a long exposure. I could take something up, at Flagstaff at a 14 millimeter lens, but I couldn't get these tight zooms unless it was something like the moon that was nice and bright.
Excellent.
So,
Okay.
it's
Well,
huge.
thank you for joining us again. I don't, most of the audience doesn't know, maybe they do, but about 4 months ago, we had another program similar to this. It's called the International Observe the Moon Night. And this is how I got introduced to several of the people that are back tonight to do the great occultation. And Kevin was with us then. So I just was really impressed with his work and the detail he puts into getting these astrophotos up and active. So we will surely see you again, Kevin. Thank you very much for
Yeah, and I
joining
literally
us.
just took this picture in the last 10 minutes, and so that's on
Okay.
my camera phone of the screen.
Oh, so I see. So
So that's the settings I'm using.
that's a decent Saturn up there. Everybody sees sort of in the upper right-hand corner. There you go. That's a pretty decent one. That's really good. Excellent.
And that's just
Okay.
with my camera phone, yeah.
I am going to, now we're kind of winding towards the end of the program. We're kind of getting to the point where we're going to start to wind down. But I got two other things I wanted to look into. First of all, Mark, I don't know, do you have, can you just come back on? Do you have another target that we could look at? Mark has an incredible setup and is able to tease really deep sky objects out of the sky. And so if you can, and if you have it, why don't you just give me the thumbs up and let me know.
Do you hear me?
Yep.
Okay, can you share so I can grab the share thing? Just quickly, just show something so I can grab the share option. I've got the Pleiades here. I can show everybody.
So I have to share so you can share? Is that what you're saying?
It's a weird thing I've got going on.
Okay.
Yeah,
Yeah, I think there are a few
Okay.
little bugs right now.
I don't see
I'll
it.
share that.
Somebody else shares, and I can grab it.
So you should see something now, right?
Not
I'm
yet.
going to calm my image down.
Okay, now I can do it. Okay, got it.
Okay, there you go. And now I can stop share, right?
Yep. All right, so now we should see the Pleiades. You guys see that?
Oh yeah, there you go.
Yeah, so this is
For
kind
some
of
of the
quick and
some of the
dirty.
Pleiades.
This is Messier M45, and it's a beautiful asterism in Taurus. An asterism is a recognizable cluster of stars that's within a larger constellation. So another example would be the Big Dipper, which is part of Ursa Major. So this looks like a little tiny dipper up in Taurus. You can see it just to the left of the moon if you've got eagle eyes. It's pretty visible on a dark night, not so easy tonight. I'm not tracking perfectly well. You can see the stars aren't perfectly round, but you are seeing I'm picking up some nebulosity around the stars. It's a bluish tinge. And if I let it go longer and I have it set up properly and the moon's not in the sky, I can get a really beautiful image with tons and tons of blue nebulosity around all the stars.
Excellent. So it's
So you
not
can see
only
the
so it's not
thousands of
only
stars.
it's not only an open cluster, so it is a cluster of thousands of stars, but it also internally around the brightest stars, there's this really wonderful wispy kind of, as you sort of described, on a bluish nebula that sort of teases out. Most people don't ever see that. I can see it in some of these stars now.
Yeah, exactly.
Rick, would Mark have a minute just to answer some questions from the audience?
Absolutely.
Yeah.
Let's take it now.
Go ahead, Spooty.
Right. So there are some questions for Kevin.
Okay.
Amber asks, what type of telescope would you recommend for space photography?
Well, that's a great question, because one of the screens we're seeing right now is when most photos are taken that are any great quality, they're starting with a telescope and then they add an image sensor to it. I've gone the other direction. I'm a photographer who got into astrophotography. So for me, it was all about adding longer lenses and then the star tracker I was mentioning earlier. So it sort of depends on whether you want to see things or you want to photograph them, or you want to start by seeing deep sky objects and then photograph them. So it's a complex question. It depends on whether you're somebody that's into astronomy or into photography.
Awesome. Thank you for that. There's another one. It's for you, Kevin. What kind of telescopes are needed to see a close-up of Saturn to see the rings clearly?
Well, as you can see from my example, that's as good as I can get. I'm at 840 millimeters, which is about the biggest lens you can buy for a DSLR camera and still take photos that aren't blurry. But most of the great photos that you'll see from even some of the other people on the panel, they can have 12, 16-inch telescopes that are now equal to 3,000 millimeters of what a camera lens would be. and I can't even buy anything like that. So again, if you're starting in astronomy and then you're adding a sensor on there, you're going to get a lot crisper images, especially of the rings of Saturn.
Awesome. Thank you so much. Rick, would you like to continue? Did we just lose him?
Sorry about that. I just stepped away for a moment. Okay, the other.
There's the Pleiades, just in case you're interested, from two
Oh, there
nights
you go.
ago. And that's
Yeah, excellent.
about a half-hour exposure with a digital camera stacking the results frame after frame. And you really see the nebulosity well here.
That's excellent. That's an amazing image. That's really super. So I'm going to retire. I hope that's not a surprise to anybody, but I'm retiring in about 7 or 8 or 10 years. And when I do it, I'm going to contact Mark Johnston, and I'm just going to get a list of the equipment that he uses, because this is absolutely stunning. This is awesome. I just think those are amazing. Well, thank you, Mark. Thank you very much. I've just got one more person I think I'm going to introduce if he's here. I understand that Claude Haynes kind of joined us late, but I was wondering if you could kind of come on the microphone if you're here and introduce yourself.
It doesn't look like he's with us in the panelists. So if he's in
He
the
isn't?
attendees
Okay.
option, then he won't be able to
Okay.
talk.
I thought maybe he was. Oh, there he is.
Okay, there. Now I can see.
Excellent. So Claude, I just when we were putting this night together, I knew we were going to have a lot of the technical, and I knew we were going to have a lot of the people that are really into the photography and into the happening and all that stuff. But when I was trading emails with you a little bit and text with you a little bit, you just got this sort of bigger, broader awareness of sort of the meaning of the winter solstice and the meaning of sort of like, what's happening to us. And I just thought I'd kind of just ask you a little bit about what you think about, what we're seeing tonight, and what it's like where you are, and what kind of people are getting together. And can you kind of share that with us a little bit?
Sure, thank you. I set up my telescope, or one of my telescopes, outside and had some family and neighbors come over, and we've been looking since sunset, and it's a lovely view. But what I would want to do is to encourage people not to just think about this as a one-time event. If you go out tomorrow night, you will be able to see that Saturn has moved a little further away from Jupiter. We've been watching it the last few weeks as Saturn has gotten closer. Now the reverse process is going to take place, and you'll get to see and watch the celestial mechanics as they happen. So tonight is the closest night, but if you keep looking, it's still going to be a beautiful view to see bright Jupiter and then less bright Saturn as it moves slightly away. And for thousands and thousands of years, humans practiced what we call positional astronomy, where things were in the sky. That changed about 400 years ago with Galileo looking up through a telescope. And now we were able to see things that we couldn't see with our naked eye. And our focus and our attention has shifted from where things were in the sky. But I think it's important for people to still connect with that, to realize that this is the way that that our ancestors figured out when to plant, when to harvest. They knew about the solstice, the shortest day, and the summer solstice, the longest day. The equinoxes for the spring and the fall were important. And as they studied the sky and knew the cycles of the sun, the moon, the planets, that is the foundation of our astronomy. The wonderful things that we have with telescopes and spacecraft are all fairly recent. And I think it's sad that some of us have lost touch with that ancient connection to other humans who looked at the sky and really marveled. They saw the constellations and they told the stories of their heroes and gods. They were frightened or overjoyed to see comets, depending upon which, whether your side won in the war of, say, 1066 with the comet then. All of those things were important to the ancients. And I think because now we take things for granted a bit and don't look up at the sky. I think this is a good time for us to kind of just take a step back and really enjoy and appreciate how wonderful the universe is, and that we can do it with our own naked eye, just like humans have done for thousands and thousands of years.
Thank you, Claude. Well spoken. And really, I also wanted, I think you share with me, to me, this particular winter solstice tonight, maybe because of this event, but maybe just because of what's going on in the world right now, I think it's actually more important. Winter solstice is the middle of winter. It's the coldest, darkest day, if you want, all that stuff. But ancient cultures, they didn't necessarily see it that way. Winter solstice is actually a celebration. This is the time when the sun stops moving towards the south. It halts on the horizon. It's not going to get any lower, and it's going to turn around. And that promise of return, that promise that things are going to get better, all of that stuff after the 2020 that we've had with everything that's been going on in our lives right now, I think that's really amazing. And the fact that people like Claude and people like the guests that we have tonight and the students that are here tonight, we're all just anxious to share what this night sky is like with the bigger public and get as many people sort of looking and watching and sharing as we can. One of the main features of our virtual night skies that we have put together, and we'll keep doing them later, is to give people something to look at, right? It's not only about the science. It's not only about what we're discovering and the finest detail of those minute sort of esoteric things in science and work. It's actually sort of just about the bigger picture. And we want people to go out and just share and look. So tonight was a great night. My driveway was full of people. We had over 700 people join us tonight and sort of like learn about this particular fascinating grand conjunction. And so Claude, I'm going to just kind of like ask you to just kind of share a final comment, and then I'm gonna help bring the program to a close tonight.
Well, you mentioned the feast, so we can celebrate Sol Invictus, the feast of the unconquered sun, which was the Roman feast on the solstice. So you can raise a glass of wine or your favorite beverage to celebrate this passing of the year. And I'm sure that lots of us are really going to be happy for the new year and to see 2020 in the rearview mirror. I think it is a great time for us to celebrate. And I think it's wonderful that so many people have joined together just to really appreciate the beauty of the night sky and to take a moment to think about our place in a really huge universe. We're very, very tiny. You can fit over 1,000 Earths into Jupiter. You can fit over 1,000 Jupiters into the sun. And I think we lose focus because we are so worried about our everyday lives. But I think we should also think it's a pretty spectacular universe, and we should celebrate that as often as we can.
Okay, well, thank you very much. Thanks for joining us. And I know you
My
were
pleasure.
sort of like down the street having a telescope with friends like we were. So I'm going to just really quickly ask my team, Meg and Kim, if there's anything else we need to cover tonight. And with their sort of blessing and say we've done all we were supposed to do, I'll take it from there and just kind of bring us to a close. How are we doing, guys?
I think we're good.
Thank you very much. So
Rick,
Kim Baptiste.
We certainly want to thank everyone for coming. There have been so many great questions, Rick, but we are.
Good. I hope you guys are tracking the questions and like sort of like trying to get as many of them answered as you can. So let me just take a moment and just remind everybody. So I'm Rick Alling, and I'm the director of the Marston Exploration Theater, and one of the coordinators of outreach activity, sort of the on-site visits to the School of Earth and Space Exploration at ASU. You heard Meg's voice just a moment ago. She's my colleague, and between us, we kind of organized to do school groups and adult groups and these groups and programs and shows. But we usually do this on-site. That's a campus thing. That's a come visit us kind of thing. Well, of course, we haven't done done that for a while. And so this is just a good opportunity for us to get together, do something totally different. And I kind of thinking of sharing something together apart. And that's kind of what our goal is. Kim is your webmaster, and she took care of putting the program together and the communications. Thank you very much. Thank you to the students, Alex and Spurti, and Alicia for your help always, and your attention to the details. And thank you for kind of working the background and the questions and all that. For my presenters, Claude and Mark and Kevin, and Ted, thank you very much for bringing your talents and your equipment and all of that to the program tonight. Remember that ASU does this kind of thing a lot, and that we plan and continue to do a program like this every other Wednesday night. You'll have, maybe somebody will chime in and remind me, I think it is January 12th that we start. And then we will be every other Wednesday for the schedule through June, if I remember right. So all of them are a different subject. All of them have something to do with watching the sky and seeing how it works. And so,
Nice.
Yep.
Thanks for the invite, Rick. Can I end with a quick view of the moon here?
Yep, you absolutely can. Go ahead. Is that Ted?
Yes.
Okay, Ted.
Okay.
Oh, I need to stop share. Hang on a second.
Okay, there you go. I will. We have a live image of the moon here. First quarter moon.
Oh, look at that.
So you're seeing a little bit of scintillation because I'm looking at it over the roof of a building, but occasionally when it does clear up, it's a really beautiful sight. I love the fact that we're looking at the Terminator. Let me see if I can scan a little bit off to the side here. There we go.
I love it how those things, how they look like they're disconnected and just hanging out in space.
Yeah.
But for the audience, what's happening is the sun is shining across this part of the moon at such an oblique angle that some of this material, either cliffs or high tops or little mountains and things like that, tops of craters, are actually in the light, and some of it is in shadow. And so you see, just sometimes you just see little bits of things that appear to be disconnected from the moon, but it's not. If you watch over time, everything kind of it comes back into connection and that stuff. It's kind of fun.
There we are. Yeah, from my perspective, Jupiter and Saturn have gone below the wall of a building, so I had to switch over.
I actually still have them just for a little bit. I probably have them for another 5 minutes, and then I'm gonna lose them too. So
yeah. Okay.
All right. Thank you, Ted. Thank you so much, and thanks to all the presenters to kind of help put this together. I am going to sign out on behalf of the School of Earth and Space Exploration at Arizona State University. Thank you very, very much for joining us. Keep watching. This particular thing isn't over every night for at least the next several nights in through Christmas. You'll be able to see those two planets getting further and further apart. And they're going to get closer and closer and closer to the sun. Remember my simulation about how the Earth is going around behind the sun? So what's going to happen? They'll get further and further apart. And then eventually we won't be able to see them anymore because they will be buried in the brightness of the sunset, and we'll kind of find the next amazing astronomical phenomenon, and we'll bring that to your attention when it happens. So thank you very much. I appreciate it. We're going to kind of sign off now. Thank you. Thank you, everybody.
Hello there.
Hi, guys. Hey.
You keeping tracking them?
Yeah, we are.